So this one, it wants me to write the new function that has the following transformations. It's going 7 units up. So up adds at the end. And left is going to go inside opposite the sign. Okay, so I'm going to make my changes in red. So I have x minus 2, that's from the original. 3 units left. Left is normally negative, so I'm going to add 3. And then it had plus 4 at the end. Oh, this is g, that's not good. And it's going 7 units up from that. So then from here, I just want to simplify. So I'm going to rewrite g of x. Negative 2 plus 3 is positive 1. And 4 plus 7 gives me 11. Okay. The next two questions are asking about stretches and shrinks. Stretches are numbers out front that are more than 1. So I'm looking for these ones that have numbers out front more than 1. One thing I want to point out, sign doesn't matter. And this is also going to go for the vertical shrink. Okay, so not 2/3 is not more than 1. Negative, or just regular 2 is more than 1. 3/2 is the same thing as 1.5, more than 1. 1/5, less than 5, not more than 1. If I look over here at the shrink side, shrink is numbers out front less than 1. Okay, so 4, not less than 1. 1/2, less than 1. 0.2, less than 1. 3, more than 1. Okay, looking at this graph, it gives me my slope triangle. So it's going down 3, right 1. Remember, slope is rise over run. I also know that this coordinate point is 1, 1. It's going to be my xy. So my slope is negative 3 over 1, which is just negative 3. Then I'm going to plug into this formula. So I'm going to have 1 equals negative 3x. Nope. Negative 3 times 1, because I know an x. Plus b. So negative 3 times 1 is negative 3. Plus b. Then I want to go back and add 3 to both sides. I get b equals 4. So I'm going to plug back in my slope and my b into the y equals mx plus b form. So I have y equals negative 3x plus 4. Okay. Number 5 gives me my slope and my point. So my slope is m, my point is xy, and I can just plug into here. I have negative 1 equals negative 4 times positive 1 plus b. I'm going to do negative 4 times positive 1 to get negative 4. Then I want to add 4 to both sides. I get 3 equals b, so I plug back in. I get y equals negative 4x plus 3. It's crazy. I did not mean for those slopes to switch. Okay. This next one gives me the slope formula and the slope-intercept formula. So this is going to be x1, y1, x2, y2. I want to plug into here. So I'm going to have m equals 2 minus 6 over 3 minus, I have to make sure I have my extra negative here, 3. 2 minus 6 is negative 4. 3 minus negative 3 is the same thing as 3 plus 3. And then 3 plus 3 is 6. So I have negative 4 over 6. This simplifies to negative 2 over 3. Then I can pick any of these points and plug in for y and x. I'm going to pick my first step. So I have 6 equals negative 2/3 times negative 3 plus b. Then I have 6 equals negative 2 times negative 3 is positive 6 over 3. 6 divided by 3 is 2. Subtract 2 on both sides. I got 4 equals b. So my answer here is going to be y equals negative 2/3 x plus 4. Really am a fan of 4 in this review. I do not know why. Okay. This one wants me to write the new g of x. So this is from the whole front side. I want to say was from chapter 1. Starting from here on, this is chapter 2. Okay. It wants me to write it based on the following transformations. It's going to go 4 units left, which is my first step, and a reflection in the x-axis, which is my second. So my first step, I'm going to rewrite this. 4 units left is changing on the inside, opposite the sign. Okay. Then I'm going to simplify, so I have g of x equals x plus 7 squared minus 4. Then my second step was my reflection in the x-axis. This, I want to point out, changes both signs outside. So I'm going to write g of x equals, I'm just going to rewrite what I had originally, and then in red I'll make my changes. So because it's a reflection in the x-axis, I get a negative out front, but I also want to change the sign of my number at the end, so now it's a positive 4. Okay. Number 8 wants me to take this function and find the vertex, axis of symmetry, and where it's increasing and decreasing. So I am going to do this on my calculator. I'm going to clear out my functions. Negative 2x squared minus 4x plus 3. Then I want to go graph it. Okay. I'm going to, if I did this on Desmos, I could just click the high point, but since I'm doing it on a graphing calculator, I have to find the vertex myself. This is a maximum, so I'm going to go second calc, maximum. It says left bound, so I want to be on the left side of the high point. Anywhere on the left side is fine. I press enter once. Then it says right bound, so I want to be on the right side. I press enter twice. And my calculator is not good at rounding. It says -1, 5 for my vertex. My axis of symmetry is always my x value, so x equals -1. It's increasing where it has a positive slope. So if I look back at this graph, positive, my calculator's not one of those. Positive slope is on this side, on the left side. So I write x less than -1. Remember, less than for left, greater than for right. So then the decreasing has to be on the other side. So it's going to be x is greater than -1. All of these 3, axis of symmetry, increasing and decreasing, they take the x value from the vertex. Am I on? Nope. Okay. Number 9 wants me to give the domain and range, so I'm going to go graph these. Okay. This one wants me to give the domain and range. Remember, for quadratic equations, my domain is always all real numbers. My range is from my low point up. So since this one is in vertex form, I know my minimum value is -5. But if I wasn't sure, I could always go second, trace, and this one was a minimum. I want to be on the left side, which I am. My flashing point's right there. Press enter, arrow over until I am on the right side. Then I press enter twice, and the calculator, I calculated a maximum, my bad. I'm on the left side, then I arrow over until I'm on the right side, and I press enter twice. There you go. It gives me 2, -5, which is my h and k. Then my range is, since this graph is going up, I want it to be y is greater than or equal to my minimum y value, which was -5. And this is a minimum, and my minimum value is at -5. So these two pieces are for my y value from vertex. Okay. Number 10 wants me to write the model of the equation with the given vertex and point it goes through. I will plug these in. Vertex is always h and k. Point is always x and y. So I'm solving for a and then plugging it back in at the end once I have it. So I'm going to have -1 equals a, parentheses, 8 minus 4 squared plus 2. So I'm going to do parentheses first. 8 minus 4 is 4. Nothing changes on the outside. 4 squared is 16. It's not full. I want to write that out front. Okay. Then I want to subtract 2 on both sides because this looks like a normal equation from Algebra 1. I have -3 equals 16a. I divide both sides by 16. I can just leave it as a fraction. A equals -3 over 16. So I want to plug back in a, h, and k. So I get y equals -3 over 16, parentheses, x. My h was 4, so minus 4, squared, plus 2. Okay, number 11 wants me to use this one, the intercept form, for the quadratic formulas. And it tells me my intercepts are 6 and 3, so P and Q. And then my point is 3, -6, so X and Y. Plug those in. I get -6 equals A. Parentheses. I'm going to plug in X twice, so I'm going to have 3 minus 6. And then 3. This one was a -3, so plus 3. Then I have -6 equals A. I want to do the math inside the parentheses. 3 minus 6 is -3. 3 plus 3 is 6. So I have -6 equals -18a. I want to divide both sides by -18. I get 1/3 equals a. Same thing as before, except I'm plugging in P and Q. So plug back in A, P, and Q. So y equals 1/3 x minus 6, x plus 3. This one is using the same formula that was just on the last one. Just kidding, it's for text form. It's already written on this problem. It tells me he shot out of the cannon, so I'm drawing a picture. You can judge me all you want from my cannon. Here's the guy. He's going like this. It tells me he is being shot out 10 feet from the ground. So this is 10 feet high, but he hasn't gone anywhere over. Then he reaches a maximum height of 36 feet. And this is 20 feet over. So my coordinate point here is 20, 36. And where he starts is 0, 10. So this is my high point, H and K. Where he starts is my X and Y. Then another way I can think of this is shot out is 0, 10. That's my X and Y. And then for human cannonball, it's backwards, so this is K, H. Okay, so then I'm plugging into this formula. I have 10 equals A, parentheses, 0 minus 20 squared, plus 36. 0 minus 20 is negative 20. Negative 20 squared is 400. I write that in front of my A, so I don't confuse it and combine it with the 36. Then I subtract 36 on both sides. I get negative 26 equals 400A. I divide both sides by 400. And I get A, this will simplify to negative 13 over 200. If I knew it simplified, but I wasn't sure into what, I would want to type it in my calculator. So let's go home. So I have negative 26 divided by 400. I hit enter. It gives me a decimal. Then I go math, fraction. Is this coming through okay? There you go. Math, fraction, and then I press enter, and then it gives me it back as a simplified fraction. Hold on, I need to move my camera a little bit. There we go. Sun is setting and getting in this video. So now that I have my A value, I can plug back in A, H, and K. So I have Y equals negative 13 over 200, parentheses, X minus 20 squared plus 36. And that's my answer here. Okay. Starting with 13, this is chapter 3. That's off the screen. Okay. And then this one I'm looking for what multiplies to 6 when I'm factoring and adds to negative 5. It's going to be negative 3 and negative 2. Then I have it set equal to 0. I want to take my pieces and set those individually equal to 0. So I have x minus 3 equals 0 and x minus 2 equals 0. On the first one I add 3 to both sides. I get x equals 3. On the second one I add 2 to both sides and I get x equals 2. I'll be honest, on the final, I cannot tell what method you use. So if you want to use factoring, which is the one I did, you can. If you want to use graphing, that's the one where you type it into the calculator and tell me where it crosses the x-axis, you can. Or you can use the quadratic formula. All of those methods will work, and I will not be able to tell which method you used, even though this question says solve by factoring. Okay. Number 14, this one I do have to solve with a very specific method. This one is the AC method. So I want to figure out my A, B, and C values. A is 3, B is 13, C is negative 10. So I take my A and C values, which is 3 times negative 10 equals negative 30. So on this one, I'm looking for what multiplies to negative 30 and adds to positive 10. I mean positive 13. So this one would be positive 15, negative 2. So then I rewrite this. I don't think I gave us enough space. I have 3x. I'm going to have plus 15x minus 2x minus 30. Then from here I split into groups. My first group has 3x in common. So I want to write 3x out front. 3x squared divided by 3x is x. 15x divided by 3x is just 5. I wrote negative 30 when it should have been negative 10. Okay. That doesn't look quite right. Okay. Then on the second group, I want to take out negative 2, because I always want to make it positive. So I write that out front. Then I just have x. Negative 10 divided by negative 2 is a positive 5. I take the outside pieces that are alone, and I put them together. So I have 3x minus 2, and then the repeated piece goes at the end. If I don't have a repeated piece, I've done something wrong. It's kind of like a few minutes ago when I was just realizing that I wrote 30 instead of 10. I knew 15 was not the number I wanted, so I knew I made some mistake there. Number 15 wants me to find the values of x and y that satisfy the equation. So what I want to do is I want to take my two real pieces, and I'm going to set those equal to each other. So I have negative 4x equals 8. And I'm going to take my two imaginary pieces, the 16i and the negative 2y, and I set those together. And then I solve. So on the first one, I divide both sides by negative 4. I get x equals negative 2. On the second one, I want to divide both sides by negative 2i. And I get negative 8 on the left and y on the right. Okay, number 16 wants me to use the quadratic formula. My a is 1, my b is 4, my c is negative 7. Then I'm going to plug into this formula. So I have x equals negative, my b value is 4, plus or minus the square root of b squared, minus 4, times my a value, which was 1, my c value, which was negative 7, divided by 2, times my a value of 1. Going to simplify it. And I get negative 4, plus or minus 4 squared is 16. I'm going to do negative 4 times 1 times negative 7. Which gives me 28. I'm sorry, this is getting increasingly harder to see. The sun is setting very quickly. Divided by 2. Keep on simplifying. I get it equal to negative 4 plus or minus the square root of 16 plus 28 equals 44. Over 2. I can factor tree 44. I get 4, 11, 2 and 2. So I have a pair of 2's that can come out. I get negative 4 plus or minus 2 square root of 11 over 2. Then I simplify because I can divide both 4 and 2 by 2. So I have negative 2 plus or minus the square root of 11. Kiki. Okay, number 17 wants me to perform the indicated operation. This I can do FOIL. So I have 4 times 2, which gives me 8. I have 4 times negative 3, which is negative 12i. Then I have 3i times 2, which is positive 6i. And then I can do 3i times negative 3i, which is negative 9i squared. Then I can combine like terms. I have 8 minus 6i minus 9i squared. Something I want to remember is that I squared equals negative 1. So I can replace I squared in my formula with negative 1. Then I can multiply negative 9 times negative 1, which gives me positive 9. I can add 8 and 9, which gives me 17 minus 6i. And then standard form, we always write the real part first, and then the imaginary part second. Okay, this one wants me, this one is, yeah, this is chapter 4. Okay. This one wants me to perform the indicated operation. I've got a minus sign, so I'm going to go ahead and change all of my signs to be the opposite afterwards. And then from here, I just combine like terms. So I have 5x cubed. Then I have negative 7x, negative 5x squared, so minus 12x squared. 2x, negative 3x, so I mean negative x. And then I have positive 2 at the end. That's all I have to do here. Number 19 wants me to multiply the two polynomials. I'm going to use the box method. I could distribute 4x squared, 7x, negative 3. Okay. Then I have 4x cubed, 7x squared, minus 3x. I'm taking the top row and multiplying by the side. So in the squared, I had 4x squared times x. This one I had 7x times x and negative 3 times x. Over here, I'm going to have 4x squared times 2, which gives me 8x squared. 2 times 7x, which gives me 14x. 2 times negative 3, which gives me negative 6. Then from in here, I combine the inside squares I just filled in by adding. So I have 4x cubed plus 15x squared plus 11x, and then minus 6. Hee. This is my final answer. Okay. Number 20, I need to divide. Divide is I can do long division or I can do the L. If I'm going to do the L, I write my coefficients out. So I have 1, negative 9, 4, and negative 12. None of my numbers were skipped, so I don't need any zeros. Then I want to go opposite the sign for the number with the x. So I'm going to write a 5 out here. I bring my first number down. Then I take that number and I multiply by the number outside. 1 times 5 is 5. Negative 9 times 5 is negative 9 plus 5 is negative 4. Negative 4 times 5 is negative 20. 4 minus 20 is negative 16. Negative 16 times 5 is negative 80. Negative 12 minus 80 is negative 92. Then I just have to plug back in my x's. You always start 1 degree less. For my exponents. So then I'm going to have, now I have x squared. I don't have to write the 1 out front. Then I have minus 4x minus 16. Now with the 92, since I ran out of places to put it, this one goes over a fraction. So it's going to be negative 92 over x minus 5. Okay, number 21 wants me to perform the indicated operation. It's raised to the third power, so I'm going to do multiplication. I'm going to do the box method twice. So I get my first answer, which is going to be x squared, 3x, 3x, and 9. I combine my like terms. I get x squared. Then I have 3x plus 3x, which is 6x. Then I have 9, which I just write here. And I'm going to take these, I'm going to use it again in the box method. Kiki, get out of the tree! I forgot to say, when this is cubed, I write it out 3 times. Okay, right here, I'm going to have x times x squared, which gives me x cubed. X times 6x is 6x squared. 9 times x is 9x. 3 times x squared is 3x squared. 3 times 6x is 18x. 3 times 9 is 27. I go back again, and I combine my like terms on the inside. So I start off with x cubed. Then I have 3x squared and 6x squared, which gives me 9x squared. I have 18x and 9x, which gives me 27x. And then the 27 at the end stays at the end. Okay. Number 22. I know last time I told you to use long division. It could be a lot easier than that. I don't know what I was thinking. I was probably sick. I can just plug in. If I set it equal, when it's asking me to find if it's a factor, I know it has to equal 0. And I can plug in negative 5 for x. So I'm going to have negative 5 cubed minus 5 times negative 5 squared plus k times negative 5 minus 30. So then what I want to do is I want to figure out what these are. Negative 5 cubed is a negative 125. I'm going to write this with the negative 5 squared. Negative 5 squared is positive 25. I'm going to rewrite this with the negative 5 out front for the k, minus 30. I can do negative 5 times 25, which is, again, negative 125. I'll combine my like terms, which is the negative 125, the negative 125, and the negative 30. Gives me negative 280. So I have 0 equals negative 280 minus the 5k. I can add 280 to both sides. I get 280 equals negative 5k. Then I just divide both sides by negative 5. And I get negative 56. Probably much easier than what I showed you last time. I don't know what I was thinking. I'm sorry. Okay. This one wants me to use the difference of cubes to factor x cubed minus 64. The cube root of 64 is 4. I can plug this in. This one's going to go into the difference of cubes. So it's going to be x minus 4 times x squared plus x times 4 plus 4 squared. So I just plugged straight into here. I went a squared, which was x, a times b, which is x times 4, b squared, which was 4 squared. Then I just simplify this, so I get x minus 4 times x squared. 4 goes in front of the x, and then 4 squared is 16. Okay. 24 wants me to factor. The difference of squares comes in at the end. So since I have 4 terms, factor by grouping. So I'm going to write my parentheses out front. My first group has an x, I shouldn't have written that either, has x squared in common. So I write x squared up front. X cubed divided by x squared is x. 4x cubed divided by x squared is 4. On the second set, I can divide out negative 9. Negative 9x divided by negative 9 gives me x. Negative 36 divided by negative 9 gives me positive 4. So now I have the same pieces. The outside pieces can go together. I'll have x squared minus 9, and then x plus 4. Then this is a difference of squares, because 9 is a perfect square. The square root of 9 is 3, so I can write x plus 3, x minus 3, and then this piece that wasn't a difference of squares just gets written at the end. Number 25 tells me it is going to use the quadratic best fit, so I don't need to do the table to find my values. I'm going to go straight to stat. I'm going to edit. I'm going to clear out my list if they have numbers, which mine do. Then I'm going to type them in. Let's just go to 4. Then I have 600, 585, 540, 465, 465, and 345. Then I go second mode to go home. I press stat again. This time I want to go over to calc. The problem told me it was quadratic, so I'm going to pick choice 5. Press enter. Yours has you go through a list to calculate. So you go all the way down to calculate and press enter. On this one, it wants me to round to, it doesn't say, but I know the computer wants you to do it to 2 decimal places. On the computer, it's a multiple choice. So I plug in. I'm going to have y equals negative 17.14 x squared, because I'm plugging in for a, plus 5.57x, and then plus 598.71. That's my answer for A. B wants me to figure out the height after 5 seconds. This just means plug in 5 for x. So I'm going to have y equals negative 1.714, plugging in 5. So I can type this whole thing into my calculator. Let's clear my screen. Let's move this up. So I have 17.14 parentheses 5 squared plus 5.57 parentheses 5 plus 598.71. Then I press enter, and it gives me my answer. It was negative 17. Which is 198.06. Okay. Number 26 wants me to find all the solutions to this cubic polynomial. What I need to do is I need to get all my terms on one side. So I want to add x squared to both sides. So I have x cubed, negative 4x squared plus x squared is negative 3x squared, minus 3x plus 14 equals negative x squared plus x. No, the negative x squared went away. My bad. Equals x plus 2. I subtract x on both sides. So the x cubed minus 3x stays the same. Negative 3x minus x gives me negative 4x. Plus 14 equals 2. Then I subtract 2 on both sides. I have x cubed minus 3x squared minus 4x plus 12 equals 0. Then I can solve this two ways. I can solve by factoring, or I can solve by graphing. I'm going to choose graphing. So I'm going to type this in for y equals. I'm going to type x cubed minus 3x squared minus 4x plus 12. I click graph. And then I'm looking for where it crosses my x-axis. It's crossing at -2, +2, and 3. Moving on, this one wants me to decide if they're even, odd, or neither. I can plug, there's two ways. I can plug in -x, so I'll do the first two. So even is going to be the same. Odd is going to be all negative. And neither is going to be a mix. So I plug in -x, and I have -x squared minus 4, which gives me a negative number squared is always positive. X squared minus 4. This is the same as what I started with, so this one is even. I'm going to do the same thing for b. So a negative number to an odd power stays negative. I already know x squared is going to be positive, minus 4. So if I compare, signs out front for the x cubed are negative, but for x they're the same. I mean, these are opposite. These are the same. So this one is neither. Okay. If I'm doing the graphing way, even reflects across y-axis. Odd rotates 180. And neither does something weird. Okay, so I'm going to start by doing C. I do x to the 5th minus x cubed plus 4x. I graph this. It's not on the screen. But anyways, there we go, now it's on the screen. So if I take this and I flip it around 180 degrees, it looks exactly the same. So this one is odd. I'm going to draw the picture of my graph. It's not quite right, but it's a sketch. Then I'm going to do the same thing for D. So I'm going to do y equals, this one is x squared plus 3x. I graph this. I can't fold this over nicely over the y-axis. What are you doing, Kiki? Can't fold this over nicely over the y-axis, and I can't, if I flip it upside down, it does not look the same. So this one is going to be neither. Kind of something like that. Okay, number 28 just wants me to find the third difference. I don't have to write the equation. So I just have to find how these numbers are changing 3 times. So to go from -2 to 7, I go up 9. From 7 to 34, go up 27. 34 to 91, I don't know this one. So what I can do is I always take my second number, subtract the first. So I'm going to do 91 minus 34, which gives me 57. Then I have 190 minus 91, which gives me 99. Going back over here, from 9 to 27, I want to change colors. From 9 to 27, I'm going up 18. 27 to 57 is 30. 57 to 99 is 42. Then to go from 18 to 30 is 12. 30 to 42 is 12. So my third difference is